have our heat pump webinar series. This is our first webinar for 2023. And today we are talking about new construction, new single family homes. So as I mentioned, I did start a recording, so we'll send this recording out to you as well as slides of the webinar. We have 3 more webinars coming up after this one. As you can see on your screen, on June 7th, there's one specific about mini splits in existing homes. July 12th, we're going to do one for heat pumps with duct systems for existing homes. And then we're going to do one that's very similar to today's again on July 26th. You can register at that website there in the corner or scan that QR code if you want to learn more and register for the rest of them. I want to thank our sponsors. Can you see my screen? Okay, it looks like you can see all the sponsors, right? Okay, my screen's just being a little weird. So I want to thank all of our sponsors today: the Beneficial Electrification League of Colorado, Energy Smart Colorado, Holy Cross Energy, High Country Conservation Center, Walking Mountain Sustainability, CORE, the Community Office for Resource Efficiency, and CLEAR, Clean Energy Economy for the region. I'd like to tell you first quickly a little bit about the loveelectric.org website. It's a good resource for everyone thinking about heat pumps or anything that has to do with electrifying your home or your building. I would recommend that you check this out. It is a one-stop shop for all Colorado rebates for heat pumps, so you can search all rebates all around Colorado. The website outlines the benefits of switching from gas, propane, electric resistance to efficient electric equipment. It also provides explanations and cost estimates for best heat pump applications, and you can find a list of qualified contractors for heat pumps on the website. Quickly, I want to mention Holy Cross Energy is a local electric provider in the greater Eagle County area, Roaring Fork Valley, and beyond. And we are talking about new construction today, so I thought it was important to point out that their new construction residential rebates are up to 25% of that total cost for the qualified equipment, and the max is $15,000 per home. So they have some really great rebates and incentives for that new construction if you're putting heat pumps in. The bottom of this page just shows what those requirements are for those heat pumps, and the nonprofits that are working with Holy Cross Energy have those same requirements. There are other electric providers in our greater mountain region. I would recommend that you reach out to your local nonprofit, possibly listed on this page, to learn more about their rebates as well as utility rebates. This page is about Energy Smart Colorado. All of these organizations you see on this page are a part of Energy Smart Colorado, and they share the Energy Smart Colorado program in their areas. They all have some types of rebates, and they're all a little bit different. So just check with your local nonprofit to find out more about what rebates are, not only for heat pumps, but for all kinds of efficiency and upgrade projects in your home. And then these are some 2023 heat pump specific rebates for our sponsors of this webinar. So these are 4 nonprofits that are up in this upper mountain region. And we all offer rebates for heat pumps. Most of us only offer rebates for existing homes. So these are rebates intended to improve our existing building stock. However, as you see under CORE, I've highlighted that they do have some new construction quarterly grants that they offer that can be used for heat pumps in new construction. So be sure to check those out. And like I said, these slides will be sent out, so you'll be able to reference these heat pumps and these websites and phone numbers when we send out that follow-up email as well. Here's a quick page about, it's not really quick, there's quite a bit of information on it, but about the income tax credits that are out there. So there's federal income tax credits and there's Colorado income tax credits. Just to point out, the federal income tax credits are just for existing homes. And then those IRA rebates that are also coming down from the federal government are coming soon. Those are not out yet, but those will be administered through our Colorado State Energy Office. So look for more information for those to come. The earliest those IRA rebates will be available is probably Q4 of this year or Q1 of next year, 2024. But check out the Colorado income tax credit. Some people don't even know this exists, but this is for purchases for heat pumps made in 2023 or 2024. It's 10% of the heat pump purchase price. And this is not only for existing homes, but also for new construction. some great websites there on the right that can really provide you a lot more information. All right, now to the main attraction. I would like to introduce to you our webinar instructor today, David Petroy, with NTS Energy LLC. I probably always say that wrong, Dave. Is it Petroy or Petroy? Maybe you should just correct me in front of everybody so I get it right.
Petroy.
It's Petroy. I always say it wrong.
That's all right.
Dave has over 15 years experience in a range of renewable energy, sustainability, and business roles. He was the founder and president of Blue Valley Energy, a successful ground source heat pump engineering, design, and installation company in Boulder. During the early 2000s, he led technical sales of solar and energy power systems for residential and small commercial businesses. Most recently, he was the sustainability manager for Golden Aluminum, one of the largest single-site industrial power users in Colorado. There, he was responsible for leading adoption and implementation of a facility-wide energy monitoring system and upgrades to reduce energy consumption on large industrial production processes. In 2017, he launched NTS Energy, a consulting company focused on providing advancing HVAC and solar solutions to homeowners and small commercial, promoting the transition to a new energy economy in Colorado. David holds a MS in geophysics from Washington University in St. Louis and a BS in zoology from SUNY Oswego. Oswego? I don't know if I say that right either.
Yeah, I guess I could leave the zoology thing out. That's kind of in there just for interest.
Dave is going to share his slides now, and we will get started with this very informative webinar. Just a reminder, you can put Q&A, your questions in the Q&A box at any time. Just click at that Q&A box on the bottom. You can certainly also put some stuff in chat, but if you're wanting a specific question answered, best way is to put it in that questions and answer box. And we'll get to those at the end of the webinar, or Dave may see some as we go along and be able to answer some of those as we go.
All right, so welcome everyone. I see I know most of you on the call, and so let's get started. Actually, I got a lot of material this time. Try to get through it in about 35 minutes or so. That's the goal. But let me just share this here. Okay, how's this? Can everybody see my screen there?
We can see your reading screen. So we see the first slide and this next slide that's
there. Can you see that one? Oh, that slide there?
Yeah, we see both slides.
Yeah, let me just try again. Let me stop share.
But if that's the case, Dave, I'm sure it's not a problem as long as we see that main slide.
Oh, I think I just messed it up. There we go. How's that?
Now we see publisher. Now we see the preview pane again that shows that second slide. So if you go, I don't know what kind of computer you have, Alt Tab, and you could use that to view a certain screen, but when you share a screen, you should make sure you share a screen that only shows the one slide.
Oh, all right. I think I know what's going on. Just a second. I will do it one more time.
Sorry, everybody. Thanks for your patience.
Sorry. Share. Used to not be. All right, there you go. Right.
We can use that. That's your publisher view, but that's totally fine.
Yeah. Okay. We'll do that. I mean, okay. Let's just do it this way. Okay, so we're going to go through some stuff. Some of you have been to my previous ones. We'll talk a little bit about heat pumps, how they advance. I think the meat of it's going to be talking about strategies for new homes and sizing and a lot of stuff in here about really things to consider and options you have. This is kind of geared toward homeowners, builders, architects. So I think everyone here knows a heat pump's just a reversible air conditioner. Anyone wants to know more about that, we can actually go through it later in the chat. But really one big thing, and I think all of us in the field are very familiar, but a lot of folks aren't. What's cold climate heat pumps? Why have they evolved? Why are they so much better? And basically in the US, we can talk around, it's only been about 20 years. And it was due to some oil price increases in New England specifically, and some other natural gas price increases back then. Folks said, why can't we use heat pumps? There was a lot of research efforts in defrosting, and there's a lot of trials in New England, in the Midwest, and Canada. And basically, the interesting thing was there's all these engineering improvements. The compressors became highly variable inverter compressors and scroll compressors, defrosting, so you could run it when it's icing out. All these designs of new metals, new fan blades. So every little thing made a difference, made it more efficient, made it operate better in harsh conditions. So this is a big thing. One was this slide here. This is outdoor temperature 0 to 70 degrees. And this is how much heating a home will need. For those of you who aren't familiar, it's millions of BTUs. To put you on scale, a typical homes might run from 36 to 60 when it's cold out. That 1 ton is 12,000 BTU. So you'll hear me talking about 3, 4, 5 tons of heating requirements. So this green line is how much heat I need as it gets colder, and it increases. The blue line, this thin blue line, is what heat pumps, I'll call them classic, before cold climate, used to do. And it was like down to freezing. They would have enough heat, and then they wouldn't work really in cold climate. So basically, in the South, they put them in for mild winters. Well, everything I talked about in the previous slide enabled them. So now a heat pump's more the orange line. Basically, it stays steady capacity down to, say, some of them -5, some of them close to -13. And so this big, huge window, this is all the heating we needed to get to this green line. All of a sudden, we can do that with heat pumps down to 0, a little below. There's a little tan wedge, and that's where you'll see there's a little auxiliary heating with electrical, or if you have a backup furnace, existing houses, you can do that. So that's number one. Number two, they got a lot more efficient. This is how efficient heat pump is. The higher the number, the better. And this is from 2012 to 2020. Basically 23, we're still about here. Probably take another jump in a year or two. But notice from here, 2012 to now, they're about 28 to 34% more efficient. This is a common HSPF you can go out and buy now, anywhere from 10.5, 11 to up to 13 with the top one. So a gain of 34% efficiency means the pricing to operate them goes down. So quickly to summarize, we have great efficiency improvements. We can heat, but we have much more capacity. We can heat below 0. We can defrost when it's icing. So I'm going to talk about different strategies, but just make sure everyone's on the level. What's a ducted system? Not much different than everyone's used to with a furnace. Heat pump looks like an air conditioner. It sits outside. It hooks in this case, to existing homes into a furnace. Basically uses the fan, heats the house. The furnace is only used a very little bit to heat the house with a cold climate scenario. With an all electric scenario, the heat pump's the same. Indoor, a unit's an air handler, looks like a furnace, fan and everything, but there's a little electric strip heat up in here, in the top here, which helps out. So that's the ducted scenario. The real advancement, I mean, if you think about how heating systems evolved, I consider this a pretty big leap forward, honestly, that this going to mini split heat pumps. Basically, these systems, they're ductless. So you have a system outside, looks like an air conditioner, but a lot of these, they're a little different. They're turned on their side, think of it that way. And you have all these units inside, no ducts, just lines to each of these. Now, the nice thing is each of these, where they are, you have your own individual thermostat control. Very little room to run these. They're super quiet, and you can do different things with them depending on your architecture of your house, what you desire. So let's look at these really quickly. They start out as just these wall units, and that's still the most common thing. And they were designed to, oh, let's put it in a room that's cold or hot. But now you've got different styles. Some manufacturers make really sleek ones. They look like mirrors, etc. So they're trying to make them more modern, more stylish. But then you've got a couple of, this one is an adaptation from more commercial. And it's a long, think of putting this and suddenly put it flush on the ceiling between joists. And really you put these at the edges of the rooms and they kind of blow into the room. So that's a nice style. This is a flush ceiling mount, multi-directional. These go more in the middle of the room. They can really adjust. These fans can adjust based on the season. So if it's the summer, it can go, or the winter, you can sort of blow it. It's cold air can go down more. If it's warm air, it doesn't have to go straight down. So you've got really nice controls on it, and it goes multiple directions. These two are more recent additions to kind of the family. Slim ducts are very nice. They can be hid in an attic. They can be hidden above a closet, a big closet. They can be hidden above a bathroom, dropped ceilings. And the nice thing is you can get 2 rooms out of one of these. And then this is the most recent thing, the air handler. So it's nice because you can sort of have a duct system, but in combination with 1 or 2 of these units. This is a nice wall unit. Don't see them much in the US. I'm not sure why, but they are available. I guess they take up wall space, but they're pretty sleek looking and nice. So the system goals, and this sounds very basic. Everyone's going like, whoa, why has he put this up? But it's good to step back and think about it. Basically, the system you get, you want to take advantage of these rebates. So you want to put a high quality system in that meets all the rebates. If you're a builder or a homeowner, you want to make sure that that's what your contractor is going to provide you. And for those Star Trek geeks out there, the prime directive in this case is no homeowner problems. People don't want to come back. Carl gave us a couple little hints of some things. So what does that mean? Well, it has to have the capacity to keep the homeowner comfortable under all weather conditions. And we'll talk about that in design, because the homeowner doesn't want to, if in the occasional time where it's -15, they don't want to be cold. And the other thing is, a big one is ensure that their bills are close to expectations, which isn't so applicable in new homes because they don't really know how much it's going to be. But a lot of times, if you're modeling a house and saying, well, I think the bills will be about this, especially in retrofits, they have expectations, homeowners, of, oh, my gas bill will be nothing, my electric bill, but it'll go up a certain amount. But I've had cases where there's too much of backup electrical and their bills are much more than expected. So you've got this balance where you've got what are the first costs, you've got energy efficiency, you want to drop that, you got operating costs, and you've got comfort. So these are all the trade-offs. And now there's more, since there's more options available to make better systems, the homeowners need to give you more information. And number one is, it used to be 30 years ago, 40 years ago, oh, I built a duct system, I put one thermostat in the middle of the house, and that's it. If it, whatever rooms are cold or a little cold, whatever rooms are hot, then now it'd be more like 1 per floor. But now with these systems, you can say, all right, 1 per floor to me is the minimum. But types of things like, well, the second floor, you've got 3 bedrooms, you've got a master bedroom or an office that you're in all the time. Do you want specific climate control in that? On the main floor, a lot of homes now, north, south, or east, west, they really want to take advantage of the light in the south, the sunshine. That's a very different scenario than what's going on in the north. And then you've got basements, which used to be just workshops or just basic basements. Now you've got everything from bedrooms to TV to laundry rooms, etc. What are you doing down there? The other thing which has an impact is an open concept design or more traditional. That'll have an influence on what your strategy can be. And do you have attics available? Architects now, for a lot of the homes, they want to duct chases and duct drops are, in the past was like, yeah, those are fine, that's what you have to do, but you don't have to do them now. So people will be asking, can I avoid those? And then the history, obviously radiant is huge up in the high country, and evolved because Old houses used to be really cold, hardly any insulation in the walls, hardly any insulation in windows, basically a really cold feeling. Obviously, radiant heating became the optimal comfort. And with boilers, it was a little more efficient than just the ducts. So it became the standard. Well, the game's a little bit different now. The new homes are built with super insulation, no leakage, nice windows. So inherently, they are not going to feel as cold. So you've got more homeowners out there or builders, there's more discussion about where do you optimally need all this radiant? Do you need to pay all this extra? Where do you really want it? Do you want it in the basement, the main floor, or so that's important. I used to go through this slide in details, but we've got a lot of stuff today, so I'll leave it for folks to read. But let's think of it today. I'm going to sort of walk through really quickly 4 core strategies. One is the old strategy, ducted systems. The second strategy is just multi-zone mini split heat pump, no ducts. The third one is a combo. You can do, and I showed with that in the slide, you can do some parts ducted, some parts mini split. And the fourth option you have is you can go radiant in floor, a certain part of your house with boilers for comfort, but then you complement that with mini splits, which do heating and cooling in certain parts of the house for certain times of the year. And you can read, there's just differences about, how hard it is to do them, etc. But let's walk through them, just talk. Well, whole house, okay, heat pump whole house ducted systems. There's not a lot of magic involved here, but there's a few key things. So if you've got a 1-level home, you're going to do one system in the basement, and you're going to add filtering, and you're going to add fresh air. I'm going to emphasize that in a few slides. Super important. And you might add, in the past, people would have big ducts in the basement, and it was not very efficient. You just need a little one, or honestly, in a lot of these homes now with super insulation, the walls, the basement, the floors, basement needs so little energy, you can actually put a little tiny electrical in there. And then, but a 2-level home, and you'll see size constraints. So 2-level home that has below, let's say above 3 tons of heating requirements, you're going to want to go with a couple of systems. And you're going to want to put one in the basement and do that first floor, and then one in the attic and do the second floor. That's kind of the most, might be a little bit more money, but that's really, in terms of efficiency, long-term comfort, best quality system, that's good. Now you can still, there's no reason that you can't do the old style where I'm going to do a vertical duct up and do one system. However, you're not going to get, you got to zone it. So now you've got to add zoning capabilities and electronics. So there's things you have to add that don't work as well, but you can still do it. And so that's kind of the basics. Still, there's, nothing magical about that. Mini splits though, and I think these are going to keep coming on because we're just sort of thinking more and more about how to do more rooms with these devices. First thing, there's a few general things to think about that are really important. One is you're not going to do the small rooms with these little, it's too expensive. Small rooms like bathrooms, closets, tiny rooms, little basement with super low loads. And what do I mean by that? I mean, if you heat it with a little electric baseboard heater, 1 or 2 feet only, or a flat RV heater, it's $50 a year to heat it. It's not a lot. And also with the grid being more renewable, it's not a huge bad impact. So that you take them out of the equation. And then what you do is you look at the rooms, and I said these are very important because you can get 2-for-1 deals off of those. So in essence, you've got typically four indoor units you can do with 1 outdoor unit. But if you do a couple of these, now you can do 6 rooms. So that's really a big deal. Also, if it's an open area, you can put, I was just looking at a house that had one end, it was a sort of a dining, and then a living area and a kitchen, and one well-placed unit on the wall is going to do that whole area very carefully. And that gets me to my third point, which is careful placement for the one. You kind of want to make sure that if it's a really long room, you got like a couple options. Do I put it in the middle of the room and get around, or I could put it at the end and have it go along? But where do I sit the most? Where do I need the most comfort? So really thinking about that. The other thing, it's not essential, but putting them on outside walls is a little better and easier for installation and drainage, but not essential. These are really good strategies for small 1 or 2 bedroom homes, or if you got a condo complex, and do that. And so I actually, because you're eliminating a lot of the headaches of the ducts, this is really the way a lot of folks are starting to go. A lot of the better builders. So combo, I'm going to say a little bit about this. I think the overriding theme of all of this talk is you've got a lot of options. You just got to, as a builder, as a homeowner, you got to think about, okay, what do I really want? What am I really trying to do? I'm going to give it just a simple little house example. So I've got a house here. This is the main floor. And let's pretend I have a basement. Okay, I got a basement. And if this house requires 2 systems, it's simple. I put one down here. I can zone it. I can have one thermostat in the wall here. It's great. I can have one. I can pick one on the office. I can do this side. Fantastic, simple. Or I got no basement, which perhaps, some houses are having. Well, then I could do the mini split, which I just described. I could actually put a unit here. I can put a unit over here. I can put one in this room. I can put one in this room. I've got 4. I got a little bit of electric heat in there. Bang, I got a great system. I should also mention, and I do later on, about locating the outdoor unit. That's always an interesting game. I'll talk about it here in a second. You kind of want to keep all these runs. So I'm going to all right, I got a unit here, one over here, one here. All right, where can I put this? I'm not going to put my outdoor unit along here because I've got windows. I'm probably going to have a patio out here. This is the front door. I don't necessarily want it by the front door. So I could put it over on here. I could, one unit's here and I'm going to run lines here, or I could put it in the corner of the garage over here. So that's an area, a lot of conversation with homeowners, builders about thinking about where does it make sense to put it. Also, I have no windows here too, so my noise factor. On the other side, I can go upstairs and I can have an attic and I can do the old game. I can duct it. But I could do a game where I duct it, and then the homeowner wants a very specific, in the retreat, it's an office, they use it all the time. So you can do an individual, maybe a ceiling unit in here with flush ceiling mount, really nice one to keep it that. If I've got no attic, which I've seen quite a bit in some of the homes up there with sort of bigger, higher ceilings, obviously I could put a drop ceiling in here and run these 2 off of one. I got another one here and another one here. So many options to think about. With the radiant in floor, you want to think about what the optimal way to think about this is. The mini split system, wherever that is in the house, wherever you're going to put those, that's what you should use for most of the year heat. That's what you should use from end of February through end of November, because your house is well sealed, well insulated, warm. Those are the most efficient. Then I put the radiant on in the months where I want, the optimal comfort. I don't want to feel cold at all. And then I've talked about this. Basically, you've got the flexibility now. In the past, it'd be, I have to put radiant on all my house. That's all I got. Now you got the flexibility. Where do I want to put radiant? Do I need to put it on the south side of the house? If I've got a really nice solar gain on that side, I maybe stick with the radiant, with just the radiant on the north. So you've got that kind of thinking involved. Fresh air systems, I want to touch on this, are now more important than ever. Homes used to leak. People didn't even have these. They just open windows. Well, why do I want one now? What do I need? First of all, you want it when it's super cold, because you don't want to waste a lot of energy. You want it in the mountains hot, not that often, getting more. But now we've got this new third game, which is called when it's really smoked. we got this smoky fire conditions. And so those are the cases you want it. What does it do? Brings in the fresh air. It filters it. There's a filter box in here. It does heat exchange. So it brings in super cold air, takes some air from the inside. It goes through this box. So an air that comes in here that normally might be 10 degrees, get it heated up to say 45 degrees, comes in, mixes in nice with the air coming back from the house, goes through, heats it up, and it goes out. And you've got fresh air coming in, and you've got filtered air, which you need. These are super important. Probably the most important place is in the basements. They're like just a sealed money box. And if you're spending a lot of time down there, you really need that. Now I'll say if there's no ducting, there's ways these can be smaller units and you can hang them in a couple port places of the house, and you can have a couple ducts dumping the air in different parts, and you can hook it with fan units to pull it through the house. So you don't have to have ducts for these to be in the house. See, do I need to go faster? Probably. So what about operating costs, or how much does it cost to live in a house with a heat pump versus the old furnaces, et cetera? Well, the best way to compare it is called coefficient of performance. That means that 1 unit energy in, how many units of heating energy out? So again, a furnace that's 95% efficient, 1 unit of energy in, 0.95 out. Electric heat gradient is 1 to 1. Heat pumps are 3. 1 unit of energy into the heat pump, it moves 3 units of heat from the outside to the inside. This is kind of the average over a year. In the mild months, say May and September, this number is closer to 4. In the cold months, really cold months, this number is closer to 2. So it does vary, but basically on the average, 3 times. So what does that mean? 33% of the only uses 1/3 of the energy. And if it's against all electric heating, which people don't do much anymore, it saves a ton no matter what electricity. Propane is usually much higher than natural gas, saves money against propane. So what about natural gas? And this, probably for the last 10 years, or well, since people have been talking about cold climate heat pumps, this is always the debate. Oh, it's a lot more expensive. Well, it's not anymore. I'm going to say they're about on par. It kind of depends on what's gas doing now. Is it way high? Is it medium? Is it low? The heat pumps are 1/3 more efficient than they used to be. So it depends. That year, the heat pump can be 10, 15% less money, can be a little bit more. So in the end, it's on par. And this gives you a real idea here. This is on the left side is the temperature in Eagle, Colorado. I'll make it bigger. Over the year, and this is the daily temperature band. Well, heat pumps, incredible. It's easy for them to work when cold climate, when it's 7, 14 degrees all the way up. So all this time of year, very easy to work, higher coefficients. And this is most of the year. Think about it. I'm not saying they don't work here. I'm just saying where it's really easy for them. And that's most of this year. That's most of the season. This is the outdoor temperature, -20, -15, all the way up to 60. And then this is the percent of annual heat. So if you add these two numbers together, basically below 15 degrees is only 18% of the year. And below 5 is only like the total of 5% or so. And so you can see that we get obsessed, rightly so, with the super cold, but that's really not the bulk of the game. I don't know if there's any builders on. I'll skip through this, but basically for builders, Nikki went through a lot of credits, but these are targeted toward builders. Okay, so how do we get a good heat pump system? I'm going to talk about each of these topics. Avoidable things that are happening, still happening, unfortunately. Equipment specs, how do you size, select, etc. So here's things that happen. It's not really a cold climate heat pump. It's basically, oh yeah, it'll heat, it'll be fine. It'll heat down to 15 or 20, and all of a sudden, oh, whatever I'm using electric strip. wow, I got huge high heat bills. It wasn't sized right. Had this instant. And a lot of these come up in retrofits, but doesn't mean that it can't bite you when you're doing it for a new home. Oh, it should have been a 5-ton system, not a 4-ton. So all of a sudden, I'm using tons of electrical backup. I'm not designing. The design temperature was not set up correctly. So I've got to undersize outdoor units. The indoor units can be too small also. For example, all those mini splits. And I haven't really, honestly, I haven't seen that case where the indoor units are undersized, but that's possible because you have to size them for the room and the area you want. You got to make sure it's big enough. And this one is big, a duct system. I think that I'd say the majority of contractors do understand that the duct systems for heat pumps have to be bigger than the duct systems for furnaces. And the reason is because the air temperature of a heat pump is only about 95, 105 degrees. So it's lower, which means it takes more air to move the BTUs. Now, those on there, don't get alarmed. You're still going to have a warm house. Remember, only trying to keep the house to 72, but you'll notice a difference. And then some of these systems just aren't put in right. And it's often related to these issues. And so these are the kind of things that happen. Nikki had a lot of stuff up in the front about cold climate and the specifications. For those of you, when you go on the internet and you're looking, you say, well, they don't necessarily say cold climate. You just look at if it's HSPF of 10 plus, they call it a variable speed or variable capacity. Then you know it's cold climate, and it's going to operate in these conditions. And these are just some examples if you're looking online. Another important thing is the noise levels. The indoor units, mini split ones are super quiet. I mean, I've slept in many bedrooms with them. You can't hear them at all when they're on low. Also, the bigger air handlers now are getting better. But you want to think about the outdoor units, and often they're going to run in quieter modes. And these are just some dB guidance numbers. You'll see dBs for low and high, and they often will run in the middle range. They'll be quiet when they're running low. They might be running high, but realize now they're running high when it's super, super hot or super, super cold. So you're not normally outside, sitting outside. And this is important, the warranty. If you're buying a good system, you need to have from a reputable manufacturer. This should be about 7 years or more. I got a few more slides. Sorry, running along. So this is, so we're going to get in a little bit about design and sizing, some of the nuances. So this is annual heating load breakdown. What it is, very simply, this is the number of hours that you're heating on the left side, 0 to 5,000. And the blue relates to that. So, wow, when it's mild out, 5,000 hours. When it's 5 to 30, 2,000 hours. When it's below 5, 200 hours, 250 hours. And then this is the percent of heating. I already talked about that. This is on the right side. So half the heating's done here, 45% here, and 8% here. So what are the two critical things when you're thinking about a cold climate heat pump? There's really two. One is, how cold can it run? Lowest outdoor operating spec. And I know a lot of us, we're a little bit spoiled because we got Mitsubishi on the mind, and they've done a fantastic job in Colorado, but they are like the best, and they're not the only game in town, and we can't design everything to be just Mitsubishi. So how many manufacturers actually have heat pumps that they say run below? Most of the ones that work with duct system are is -5 to -10 range. That's their minimum. So the big orange line, it's in the best interest of everyone not to think, I mean, that's the perfect lab conditions. I'm not going to design and say, man, I'm running that heat pump all the time to -13, -15, whatever, -10 above its specs. That's just not prudent. So so one way here in design to think about is as for the ducted systems, I'm going to think about designing. So, man, that system can get the house down to 5F outdoor. And that gives me a little bit of buffer above this -5 to 10 range. And then for mini splits, I can design it for colder. That gives you a little buffer of performance, which is critical. And then the capacity up in the high country is a challenge because you've got elevation, high elevation. So you really want to say, for ducted, what's my capacity at 5 degrees? I need to make sure it's going to heat at 5 degrees. And how many systems can that be? Well, here's the capacity at sea level at 5. And here, if I take D rating, which is about 23%, and I've got a few manufacturers in this range, major manufacturers. So think about 9, but really, I've got about 3 tons of heating in any one given heat pump system up there that I can do. So remember that. That's the key number, 3 tons. Once I'm going above 3 tons, I got to think of other systems. And so thank you, Mary, for reminding me. As everyone knows, insulating and making the best shell, good windows, getting those loads down is the most important. You can get it to 3.5, a little buffer. You can get away with one good system. So I mentioned this. So what do? If you're going to do a ducted system, you got to size it so it gets down to, I'd say 5, but there's a range, 5 to 10. And then that means that system typically, if I have a system at 4 tons, like I go on to Carrier's website and they say 4 tons, basically that means it has to be a cold climate. It can do 90% or more at 5 degrees. It has to be able to keep doing that. And I mentioned it before, 1 heat pump size down. The mini splits, you can go a little harder. You can say, all right, mini splits, these super cold climate ones, I can size it to -5 to -10. It should be able to do the whole house down to that one. 4 to 6 tons, I'll go fast. You basically got to get 2 systems, or you can, if you want, there's a downside. You can pair it with the furnace, but now a lot of your heating is going to be with the furnace. This is kind of a new thing to think about. When in doubt, you got to make sure it's big enough. And it goes a little bit about conventional wisdom because people were like, wow, don't oversize. But that's when the old systems was on off. And here's why. So in a perfect world, I do a manual J. Well, that house is either going to heat, keep heat better or might be a little worse. I don't really know. The system spec, it says it can do this. That's perfect factory conditions. Then it's shipped from the factory. Everyone has a little variation. Then you do the best field installation possible. It might be perfect like the factory or might be a little less. Then you've got harsh winter storm conditions, blowing like crazy, snow. That definitely decreases it a bit. And then you've got, annual performance. Any piece of equipment slowly gets a little bit worse. You've got to really maintain it. So over time, so you've got kind of these things. This is the real world. You got to make sure, whoa, don't do it so tight. I have no room for air because it's not going to cost you. The price difference between 2 system sizes is not huge relative to the big picture. So 3 more slides or 4 more slides. So we got this Colorado Eagle, Colorado climate. I've got an outdoor temperature I'm focused on the really cold, -20 to 10. And each blue dot here, this is the number of hours per year. So this blue dot represents 5 to 10 degrees. I'm 160 hours per year in that temperature. About 120, 0 to 5, drops off. 40, -5 to 0. About 20, 30, -10 to 5. And then it really goes to nothing, less than 20 hours, talking a couple nights. This is average. I mean, it might vary on a cold winter. Cold winter, these might shift up. But basically, we're looking at this zone. And remember, ducted system, I said, heat pump all the way down to here, take care of everything. Now you've got this sort of gap zone here. And it says, well, what do I got to do? I got to put That's why you got a little, call it auxiliary electric inside the unit, which is going to work together. And that auxiliary electric does most of the heating. The heat, depending on the heat pump system controls, some of them can work in tandem, but you really got to think about when you get down into here that the electric's going to do it. So you've got to size the electric to be able to do it when it gets really cold. Now, the orange block is the block that the mini split, the super ones, can do. So in those cases, if you make sure that mini split sized into this -10 to -5 range, basically you can get away without any extra electrical, because honestly, with the wall mini splits, electrical aux is a little tricky. It's not in those units. You have to have like separate little things. So, so this is very important, and you got to take into account when you're doing electrical inside the unit. This is, they call them kilowatts sizes, 5, 10, 15, 20. It's a lot of amps, big amperage on the breaker side. But notice this is if a baseboard, but in Eagle, if you have electric in the air handler, it decreases, also derates that. So a 68,020 amp at sea level is 52. So that's got to be taken into account and thought of it. So it's really important to minimize this electric strip use and maximize the unit's efficiency. And here's a few ways things can be set up that make a big difference. So often the strip heat will be big, but the controls should be that you can stage it in 5 kW increments. Because the bottom line is, if I have 20, because, oh, wow, maybe -10 someday, but you might never use that. Like it might just go 5 kW, 10 kW. That's all I ever need. The other thing is some of these systems, the more sophisticated ones, can work in 2 modes, comfort and efficiency. Say it really fast. Comfort means if it's starting to drop in temperature in the room, I better turn that electric back on to help. Like I'm not going to give the heat pump a long time. And I mean by a long time, like 20 minutes. I might, after 10 minutes, say, oh, I better put a little electric in. Efficiency mode says, no, let the heat pump run longer, do the job. And then you're going to make sure the outdoor temperature is set right. A couple of things about night use. Holy Cross, fantastic brochure about this. Different than a thermostat. Nighttime setbacks, not to save energy, only if you like to sleep and it's cold. And if you do like to sleep when it's cold in the morning, you can't just say, go back up. You have to say, oh, 5 a.m. I'll go from 64 to 66, 2-degree max. 6 a.m. I'll go from 66 to 68. So you got to just kind of slowly work it back. Otherwise it goes, oh, I got to heat this house up electric. Don't set it back during the day. Just keep it set constant. That's most efficient. And in the winter, if you feel a little cold, turn. Mini splits, a quick thing about those. When you're doing that kind of strategy, you got to size for each room. Like you got to determine the load in each room. And you actually want to size them bigger, not bigger. You want to say, okay, I have a mini split unit. I want to make sure that can heat that room when it's -10. Because even though the outdoor unit, if you add the totals of the 3 to 4 indoor units, it might be more than the outdoor unit. That's okay. Because all 4 of them are never going to really run at once. Every 4 rooms in the house aren't going to all of a sudden say heat, heat, heat. So usually it's doing 2 or 3 and it's switching. It's going, oh, these 2 need a little heat. Oh, that one's done. Now I'm going to do this one. So you can read this. It's called load diversity. Good outdoor unit. Basically you can put the outdoor unit in the south side. It helps a little bit. North side, not so great. You can still do it. And wind, well, someone said don't call it wind chill, but I looked it up. Like these things do get a little less efficient in cold, harsh winds. So if you have, if you could put a little landscape wall, a little shrubbery on the west, that's good. Make sure it's above the snow height. I don't have people shoveled out. If it's on the ski slopes of Vail, it's got to be up higher than if it's in Rife. And this is something you read on the internet. A lot of people don't put snow shelters on. They're not necessary. Don't do it. you could cause more harm. Well, the side ones, they make third-party ones that are nice. I'm telling you, to me, keeping snow off, keeping leaves and stuff out can't hurt. The thing is, it can't impede the flow sideways. I should put a picture here. The normal ones are the ones that look like AC flow goes up. The only danger is if you build a little thing, shelter over, you got to have 2 feet above it. But that's okay. You can build something that keeps everything up. And sort of a bunch of the lines and stuff. Ducts, super insulated, well sealed, etc. They got to be designed for heat pumps, mini splits, a bunch about the refrigerant lines, etc. So we've got all that. That's kind of summary, and I'm over time, but I'll stop there. Thank you.
Thanks, Dave.
Questions?
We don't have any questions in the Q&A, so I think we will wait and send out a follow-up email and see if we get any questions from that email.
Yeah, sure. Hi, Mary.
Thanks, everybody.
Who's
for
left? A
coming.
few people left.
Hello, that was really good. We'll definitely put it on Core's website, and we know of quite a few new all-electric being built. So we'll
Yep.
make sure and send it to them once we get the recording.
Okay, good. And I'll work on, next time will be faster.
Thanks, Mary. Can
We
you go to
gotta
that
figure
next
that out.
slide, Dave?
Yeah, next one. Here we go.
Yeah, so these are the rest of the heat pump webinars we have. Next time it's more specific about mini splits and then a duct system, and then we'll do this new construction webinar again. So
Yeah, these will be, yeah, the next ones won't be as long. But,
sounds
all right,
good.
anyway, that was fun.
Thanks,
Thanks.
Dave. Everybody have a great night. Thanks for attending.
Okay,
Thank you, guys.
all right.
Bye.
See you
Bye-bye.
later. Bye.
Bye.